Good evening, everyone.
Good evening. How are you today?
I'm well. I'm well. Professor, I have a question after, if you want to do it after today's class. It's concerning the Excel 3. I was not able to open it. It says
That's true.
Yeah, it says that it's in progress or something of being downloaded. But I was able to start Excel number 2. And I have a problem. I'm having a problem when I get to the part where I'm doing the graphs. When I put in the equations that you give, my bar graph doesn't look like yours.
Yes, that's true.
I sent you an
Did you follow the instruction on the number 2?
right. When you tell us to put in, I think it's A2 to A27, and then you say put in. It's not looking nothing like yours.
We'll figure this out at the end of the class. Let's see.
Okay.
Professor, I have the same problem too. For the histogram, I couldn't follow the directions as you stated on in the question, because it didn't work for my own computer. I don't have that steps there. And I log into the tutorial class. The man helped me too, but he couldn't do it. He said he will send me a message on an email, and I'm yet to receive anything from him.
Yeah.
Well, if that one doesn't work, you can use the method. Remember, I posted videos of the session where I showed you those things. You can follow the one in my video.
Okay.
Okay, I'll try that soon.
You can follow the examples in my video. That will give you the same result.
A question
Okay.
also. I have 2 questions. The first one is, I don't know if you've answered this question already, but it still says that the Excel 2 and 3 are overdue.
They're not overdue. I think there's a problem with Excel 3, so maybe I'll remove it.
No, both of them still say overdue. It says that they're due January 3rd of last year. I think that you made a mistake and haven't changed the date yet on your side.
Well, you did you just log in?
Yes, I saw something like that too.
Yeah, it still says that it's due last year, 2020.
January
3rd.
It's coming up missed.
Please mute yourself. You can see the screen, right?
Mm-hmm.
Can you?
Yes.
Yes.
Okay.
Yeah, that's for last year. That's January. All those Excel assignments are from last year.
Let me fix it now. Probably that's the problem now. Okay. So, see, January 2022. Okay, that's the problem.
Yeah. And then my second question is, do you want us to submit the Excel assignments as PDFs? Because if we do it as a PDF, you're not going to be able to click on our box, like our Excel.
No, submit an Excel file, not PDF.
So do you have something on how to do that too?
You go to the Excel and follow the instruction on the then and put it. So when you finish it on Excel, you upload the Excel file.
So will it work even if I don't have it downloaded to my computer? Because I'm using Office 365 on Google Chrome.
Well, I would suggest you use a library computer, or you use a computer that have maybe a family friend or a friend, or the library in your neighborhood that have Excel that you can, because that Google document, I'm not sure.
No, I'm not using Google Sheets. I'm using Excel through Google, on Google, like the internet.
Yeah, that's what I'm saying. They may not. I don't know if they will show me work if I click on your answers. That's why I'm to avoid that
Yeah,
confusion.
because you
And
told me not to use Google Sheets, so I still downloaded Excel, but I'm using Excel on Microsoft 365.
if you're using Excel on Microsoft 365, actually it will, if that's the one you're using, then save the file. Don't save it in 365, save it as a regular Excel document and then email it to me.
Oh, so don't upload it in the Excel assignment number 2. We had to email it to you.
No, upload it there, but you have to save it first as a Excel workbook. Then you upload it.
Okay, so download it as an Excel. Okay, thank you.
So I've updated this for assignment 2. Let me Excel assignment 2. Let me do the same for Excel assignment 3. And then that should take care of the problem. The first person that asks a question tonight, this will take care of that problem. I have now updated it. Now, I recommend that you watch my video. Remember, when I gave an example how you can draw histogram in Excel in one of the videos I posted in Canvas for you. So you can follow that instruction there as well. If you're not able to follow the one on the Excel assignment, you can follow the one I used when I taught that section. Okay.
Okay. Hello, sir.
It's still the same thing. It's just that Excel have different versions. Some this version we follow this method. Another version we follow a different method. The state is there. You still arrive at the same outcome. And also, so long as your histogram is a histogram, really, it doesn't have to look exactly like mine. So long as it is a histogram, yeah, real histogram, it's still good. You see what I mean?
Yes.
And by the end, I will also show you a quick way you can get this histogram, maybe another example, but I already did it in one of the videos that I posted for you in Canvas.
Professor, I have a problem with my homework 1 and 2. It's not even transferring over into my grades. It keeps saying missing, but I had sent you a message earlier, but you never got back to me.
Oh, it doesn't transfer automatically. I will transfer all the grades this weekend. I didn't do it last weekend because last weekend you know what it is. It's Christmas, so I did a few. But this weekend I'll transfer all of them.
Okay.
So I think I mentioned it already at the beginning. I said at the beginning of the class that if it doesn't see a grade on the Canvas, don't panic because I will transfer them manually.
Okay. And can I ask just one more question, Professor, about Excel 2, where we put in the what's that? The relative figures, and you tell us I got the same numbers.
Relative frequency, right? Relative frequencies.
Frequency, I apologize. Yes. And you say that when you round it, you give the 6 numbers. So that, do you want us to round it to or leave it as it calculated in Excel?
It doesn't matter to me that way, so long as you got the answer for relative frequency.
Okay. Yes, I got the same numbers.
Whether you round it or not, I'm good, so long as the answers are correct. Okay.
Yes, thank you.
Now, in the online homework, in the homework online, the question will tell you how many decimal places to go, or how many, that one you have to be specific in those one. But the one that is that one I grade them. I grade them, so I know if the answer is correct or not. Rounded or not rounded, it doesn't matter to me.
Oh.
Professor, after class, can I share my screen? Can I share my screen with you? Because I'm not seeing anything about, downloading what you want me to do. So can I just share my screen with you after class?
What again?
For the Excel assignment, like on Excel. Can I just share my screen with you real quick? It's not going to take long.
I'm gonna open it. Let me show you.
No, not on the PDF. Yeah. Oh.
This is the assignment. So what is it? You don't see this?
No, I'm talking about on Excel on my computer. You want us to save the link and stuff, but when I go to
okay, in that case, watch my screen.
Okay.
This is how to save Excel. Can you see my Excel?
No, your screen is frozen.
Can you see it now?
Yeah.
You go to File. save as.
Mhm,
Then you see where you have PC. I
mhm.
don't know how you see it on your screen, but you choose the place to save it. Like me, I like to save it mine in my flash drive. You can choose to save it on your desktop if you like. It doesn't matter. I've already saved this on my flash drive, so I can just save it on my desktop. Then you type the name you want to save it. Choose where you want. Like me, I save it as a workbook. So you can choose it from here. Then you click save, and it will save.
Okay, yeah, I don't have the same type of computer, so I don't think it's gonna work.
What I do, I would suggest is maybe after class, you can show me your screen. Yeah.
Okay.
All right, let's start. No more questions. Let's begin and get this out of the way. Just give me 1 minute. Let me take care of this. I opened too many documents, so I'm gonna close some of them. Now, this is what we have tonight. Can you see it? Tell me what you see on the screen.
Introduction to probability.
Yes, that's what we're gonna be doing tonight. So the probability of an event means the likelihood of that event occurring. So we use probability every day. In fact, many examples we'll be doing on probability have to do with gambling, because the gamblers are the people that first use probability. Eventually, it was discovered that it can be used in other areas. So, for example, you can say that you know that you're gonna wake up by 7 o'clock tomorrow morning. Then you can say that the probability that you woke up by 7 in the morning is 1. That means you're 100% sure that you woke up at 7 o'clock. So stuff like that. So an event has a probability of 1 if you are sure that it will occur. For example, if you have a coin, let's say a coin, you know, a coin have head and tail. So the probability that of a coin toss resulting in either a head or a tail is 1, because we are 100% sure that head will occur or tail will occur, you know, when you toss it coin. Now, for impossible events, the probability that they will occur is 0. For example, the probability that a coin will fall flat without either a head or a tail is 0. Talking about a fair coin. Now, how about this? It is 6-sided dice. The probability of getting a 7 is impossible, so it's 0. Now we're looking at the basic concepts of probability. Let's start with the probability experiment. A probability experiment refers to those chance processes that always lead to an outcome. You know, for example, when you flip a coin, you can have an outcome, which means outcome. Let me put it this way. When you flip a coin or you toss a coin, the outcome can be head or tail. When you roll a dice, I'm sure you all know what a dice is. Look at the dice right here. See, dice. See? So when you roll a dice, the outcome can be that it is 1 showing up, 2 showing up, 3 showing up, all the way to 6. How about this one? When you buy a lottery ticket, the outcome can be either you win or you lose. So a probability experiment is any chance process that leads to an where the final result that we call outcomes. Okay. Now, these are very important whenever you are solving probability. You need to know what the sample space is, and also what the outcome is. Then with that you can be able to figure out what the probability is. So let's look at sample space in a more elaborate form. The sample space is a set of all possible outcomes of the probability experiment. So we have sample space. For example, if you have this experiment, let's say that this is the experiment. Okay. Let's say this is an experiment. Probability experiment. Then outcome. All the possible outcome from the sample space. Okay. Rolling the dice. For one dice, you know that the dice have 6 sides. So all the possible outcomes we include 1 showing up, 2 showing up, 3 showing up, 4 showing up, 5 or and 6. These are all the possible outcomes. How about this? Picking a day of the week. See, day of the week. The week. The outcomes include Monday, okay, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. These are all the possibilities for a week. So that's give you the sample space. So that I'll call it the sample space, not outcome, sample space. All the possible outcome of a probability experiment is sample space. Now, sometimes we can use a tree diagram to calculate the sample space, to get what the sample space would be. Sometimes we use tree diagram to do that. We'll come to that eventually. But at least you get the point. Now, remember I started with this definition that the probability of an event means the likelihood of that event occurring or happening. Now, what are the events? The events consist of a set of outcomes of a probability experiment. And there are 2 types. We have the simple events in which there's only one outcome. For example, if you roll a dice, if a dice is rolled and a 6 shows up, so that means they say you roll a dice, and getting a 6. So in that case, the outcome, the event is getting a 6, of which the outcome will be 1. Okay, only 6. And if the event is getting a 3, or even a 1, rolling a dice or roll a dice and getting a 2 or a 3, whatever, doesn't matter. So it's a simple event. 2 showed up. Yeah. Now, compound event is where there is more than one outcome. For example, let's say that you roll a dice, you get an odd number. Roll a dice and get an odd number. In that case, it's a compound between odd number in a dice, or even number, even or odd, doesn't matter. 1, 3, and 5. See, more than one event. Okay. So that's the difference between compound and simple events. Question on this? Any question? So,
Professor.
Yep.
You're saying that sample space is a set of all possible outcomes,
Yep.
while sample events is just one outcome.
It's a simple event, not sample. I didn't say sample event. Say simple event.
Simple event.
What outcome? Yeah. What if an event that has only one outcome? I just give the example here. Sample space is all the possible outcomes, all the possibilities. For example, if you look at the card, all the possible outcome in a card is there are 52 cards. Now, days of the week, all the possibilities for that day of the week is 7 days of the week, Monday to Wednesday. So that's a sample space. So it's different from what you are from the type of event. Event can be a simple event or a compound event. Now, any other question before we move on? All right, good. Now, approaches to probability. There are 2 types of probability. We call it the classical probability, empirical or relative frequency probability, and then subjective probability. Now, subjective, we don't really use them much because it is subjective. But classical probability and empirical probability are the one we use more often because those ones can be mathematically estimated. Yeah. Now, let's start with classical probability. Classical probability have to do with sample space. So under this approach, we calculate the probability of event using the sample space. Okay. So under classical probability, for example, the sample space for a dice is fixed. So that means probability of any of the outcome is 1 out of 6. The sample space for a coin is 2. Because the coin has 2 sides. So the probability of getting either head, getting any of the outcome, the head or tail, is 1 out of 2. So you can see that it is based on sample space. Please mute yourself if you are have on TV. Please mute yourself. Hello, can you mute yourself, please? Now, for a card, the sample space is the 2 cards. So that means probability of getting any of those suits or any of the cards component there. I don't call it component. That's what they call it. The suits or any of the card name, king or queen, king, queen, spade, any of them is 1 out of 52. The day of the week, 7 days. So the probability of selecting any of the day, maybe Wednesday, is 1 out of 7. So classical probability is based on sample space. And under classical probability, we estimate the probability of an event using this formula I'm going to show you. Probability of the event, maybe probability of event A or event E will now become under classical because it is based on sample space. It is based on sample space. So the probability of the event now becomes equals number of possible outcomes, number of ways event E occurs, or number of outcomes. Number of outcomes of event E divided by the sample space. So total number of outcomes. Total number of outcomes in the sample space. So that's basically what it is. Number of ways event E occur divided by number of total outcome in the sample space. Okay, so under classical probability, we use that formula to calculate probability of event. Okay, number of ways event E occurs divided by all the possible outcomes in the sample space. Can you see the screen here?
Yes.
Good. Now let us do an example. Before we do an example, I want to explain the concept of empirical probability. So empirical probability is based on, in this case, we have to estimate the probability by ourselves by observing the number of occurrences and calculating the probability from relative frequency. Okay. So we'll come to that. Let's start with classical probability. Yeah. But the subjective is different. That one is based on educated guess. So, an experience. For example, a doctor might say that based on his diagnosis, there is 40% chance that the patient will need a surgery. Where I have seen people that, I mean, they can be right sometimes, but there are also some people that we are doctor recommended surgery, but eventually they didn't have the surgery and they were treated in a different form. Or sometimes those seismologists might say that there is 30% chance that it's an earthquake. I mean, based on his own experience, not from what he did from using the actual forecasting method, just based on his observation or her observation. So, you know, because of this, we don't use this type match. We use only empirical. Now, let us do examples on classical, which is based on outcome of the sample space. Yeah. Now, look at the first example. You say, find a sample space for rolling 2 dice. 2 dice. Now, remember that the first dice 1, how many possibilities? 1, 2, 3, 4, 5, and 6. And dice 2 is also have the same thing, you know. So when you roll them, okay, you will discover that they have the same this angle. So, but when they are rolled together, you can see that dice 1, because it says the question says find the sample space for rolling of 2 dice. Dice 1 have all this outcome dice 2. So if you roll them together, see, this is for dice 2, this is for dice 1. So when you roll them together, now it might be that 1 shows on dice 1 and 1 shows on dice 2. You can see it right here, 1, 1. Okay, it'd be that 1 shows on dice 1 and 2 shows on dice 2. So 1 and 2. You can see 1, 2. So in that following that method, you get 1, 3, 1, 4, 1, 5, 1, 6. Now, it might be that 2, when you roll them together, 2 showed up in dice 1 and 1 showed up in dice 2. So you got 2 here, 2 in dice 1, 1 in dice 2. It can be 2 show in dice 1 and 2 shows in dice 2. So it can be 2 in dice 1 and 2 in dice 2. So it can be 2 in dice 1 and 3 in dice 2. It can be 2 in dice 1 and 4 in dice 2. And so if you follow it all the way down, you're gonna get all these outcomes. So that for 2 dice, excuse me. Yeah. So that for the 2 dice, the sample space will now become if you count all of them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36 possible outcomes. So that's sample space for 2 dice. Any question on that? No question, excellent. Okay. Let's see. So find a sample space for a card, right? Someone say find a sample space for drawing 1 card from an ordinary deck. So you can see the deck of cards. Okay. Solution. You can see the sample space here. Solution, but this is how you solution. You can see the different suits. The suits. Okay. And a card in each suit. Okay, we have 10 minutes left. The different suits and the card in each suit. Number of cards. Okay. So we have the suit club. I think I'm gonna add more. Okay, club. We got diamond. Got hat. Got spade. This is sample space. Total sample space, total. So for a club, how many cards? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 13 cards in that suit. For all of them, diamond, consider it is 13 as well. Heart is also 13. If you count it, you see the 13. Then spade is also 13. So to get the number of cards in the suit, the samples, to get the sample space, add all this. So as we go, we have in this form. So 13 plus 13 plus 13 plus 13. We have 52 cards. So the sample space is 52 cards. 52. Okay. So that's basically answered the question. So we can now solve examples on classical probability. Okay. Now, the first example we solve is on a card. Classical probability is a card is drawn from an ordinary deck of 52 cards. Find these probabilities of getting a jack, of getting a 6 of clubs, of getting a 3 or a 6 or a 3. Yeah. Let's see. Solution. Okay. Of getting it says of getting probability of getting a jack. So jack will be equals, how many jacks do we have here?
4.
So 4 jacks, right? 4 out of how many cards? They are all together. Count them, they're all together 52 cards. We found it from here. 4 out of 52. Which is if you go to your calculator, 4 by 52. Okay, 4 divided by 52 is 0.0769. Just go to 0.077. Round it to the 100. 0.077. So 0.077. Or if you like, you can write probability as a fraction or as a percent or as a decimal. So this is equivalent to saying 7.7% chance of getting a jack. Questions? Any question on this? Excellent. There's no question. So this of getting a 6 of clubs. That is a 6 and a club. Now, look at the clubs right here. These are the clubs. Only one of them has the number 6 on it. Just this one. So only one of them. So probability of getting a 6 of club, probability of a 6 of club equals like only one card of 52. which give us if you look at the calculator, 1 out of 52. So you have changed this to 1. 0.019 to I usually run to the nearest 1,000 or hundreds. 0.019. Okay. 0.019. Or if you like, and write that depending on what the equation says. 1.9%. Yeah. So that is basically what it is. As C says, of getting a 6 or a 3. Probability of getting a 6 or a 3. Okay. It will be equal to probability of getting a 6 or probability of getting a 3. So 6. How many 6 cards have the number 6 on them? Now 4 of them will have 6. These are the cards that have 6. 1, 2, 3, 4. 4 have 6 on them. So 4 out of 52 cards plus of getting a 3. So how many cards have 3 in them? See?
4 also.
4 as well. Okay, correct. So 4 out of 52. That gives us 8 out of 52, right? Which was the required probability. 8 out of 52. So we go here and the calculator and put 8 out of 52. 8. That gives us 0.1538. So around there is 0.154. 0.154. Okay. Or if you like, you can call it 15.4% chance. Don't write 15.4 because 15.4 without the percent sign, you make your answer wrong. Why? Because probability can never be bigger than 1. So, but if you put percent on the side, that tells us that it's less than 100%, which is 1. Okay. Questions? We have 2 minutes left. So I think to save time, I mean,
Can you scroll up to the question?
huh?
The deck of cards. Can you scroll to it up?
Yeah.
Yeah.
So here. What do you want to know about the deck of cards? You have a
I
question
just
on it?
want to, no, I'm trying to see the 3, the one that has 3 on it. I can see it's
Yeah, it's right here. 1, 2, 3.
3, 4. Yeah. I get it. Thank you.
You're welcome. So, any other question before we have less than 2 minutes?
Yeah, before you go, have you posted yesterday's lecture?
Yes, I did. I think I uploaded it as let me see. I uploaded it as
We're under file.
Let me. I have to open the class. I used it then yesterday's this is BCC, right? Let's see if it can open it. How many minutes we have left? Less than 1 minute. So I use it. I think I call it yesterday, December Wednesday lecture notes, something.
Did you put it in files or in announcement?
Yes. Scroll down, you'll see it.
Okay, thank you.
Let me because we'll be timed out in a minute. So let me log out. So I will see you log back in after 10 minutes, okay?
Okay.
Then I'm able to end it, put it there.